Hey, so I'm sure you weren't expecting to see your parent here, and certainly your parent is not a quadratic function, but there is something called a parent function of quadratics and actually all functions that you'll talk about whenever you're learning other math courses. So the parent function for a quadratic looks like what I have written here. And some people say that this is the bare bones equation, where there is nothing to it except for what makes this a quadratic function, which is the square. So when you're lacking anything else, and it's just the exponent or symbol that makes a function what it is, that is called the parent function. Now, each parent function has a different graph. This graph, we know, looks like a parabola or a U shape. So in order for us to find the parent function, all we have to do is substitute some values in. I've created a table over here for us to discover what it is. So we plug in 0 for the x over here, and I end up getting y equals 0. So that together makes an ordered pair 0, 0. And that is, in fact, where my vertex will be in the parent function. Now, I just know this because I have graphed many, many of these, and I'm also a math teacher. So, of course, I know that that's going to be your vertex. I'm going to now plug in the 1. So whenever I plug in 1 into my squared function, I just get 1, which makes then another ordered pair 1, 1. So I can plot that. And then lastly, I'll plug in the 2. Now, if you're thinking it's going to be 2, you're wrong. Even though the pattern so far has been 0, 0, 1, 1, whenever I square the number 2, it actually ends up giving me 4, right? 2 squared is 2 times 2, which is 4. So the ordered pair 2, 4 is what I can plot for that. Now, I always say that 5 points is a really good starter for your graphing quadratic functions. And remember that quadratic functions are symmetric across the axis of symmetry. The axis of symmetry always goes through the vertex and then reflect it across. So I can actually gather more points here to make a nice shape for my graph. Now, the graph doesn't matter as much as these points do. So I'm going to go ahead and back it up and just put the points back on the graph. Now, you can memorize these points. You're going to be using it quite often. But you can also create this table every time if you have to, if you forget where a point goes. But it's always 0, 0, 1, 1, 2, 4, and then you reflect across, negative 1, 1, and then negative 2, 4. That is always going to be your parent function, what it looks like without connecting the dots.